Welcome back, students. Today is the last topic of the first chapter, that is relations and functions of standard 12. So we have read basically three things: equivalence relations and your inverse and its types of functions, and we are going to solve some of the CBSE board exam questions which has been asked frequently in the exams and how to solve them. So today I am going to take in fact three questions, very important one, and I hope that you will understand the solution. Now let me take the first question itself. Here it is in front of you. If the function f from R to R be defined as f of x equals 2x minus 3 and g of x equals to x cube plus 5, then find f of g of inverse of x. So now I am going to solve this question. So I am clearly having f of x is 2x minus 3 and g of x, it is x cube plus 5. So now let us find first f of g of x before finding its inverse. In fact, I have to find the inverse. Before finding the inverse, let us find this one first. F of g of x, which is equal to f of x cube plus 5, and I can see that f of x is twice of x minus 3, so f of t will be twice of t minus 3, f of k will be twice of k minus 3, so f of this one will be twice of x cube plus 5 minus 3. So if I solve it, this is twice of x cube plus 7. I think it is getting clear. So f of g of x, it is 2x cube plus 7. So whenever I have a function and I have to find the inverse of this one, so for that let take this one as y, 2x cube plus 7. Now you convert x in terms of y, that is twice of x cube, it is equal to y minus 7, and x cube, it is nothing but half of y minus 7. Now when I am having this one, then I will have x cube, it is equal to half of y minus 7 raised to the power 1 by 3. This is whole. So in fact, in other words, this is nothing but cube root of y minus 7 whole divided by 2. So now, so this is x, not x cube. So now x, what is x? If I will write f of g of x, it is equal to y, then clearly x can be written as f of g of inverse. In fact, this f of g will go to that side and it will become f of g of inverse of y. That is equal to, I have got, this is clearly y cube root of y minus 7 by 2. But look at the question, I have to find f of g of inverse of x. So hence f of g inverse y, I was having cube root of y minus 7 by 2. So if I will ask you f of g of inverse of x, it is nothing but cube root of, just replace y by x here, it is x minus 7 whole divided by 2. So this question, I think it is getting clear to you that how to find f of g of inverse of y. So now let us proceed to the next question. This one is the question. Now look at this one. Let f equals to n to n, and it is defined in this way: f of x is 4x square plus 12x plus 5. During the lesson also I told you these are quadratic equations, and children, you face a bit difficulty in solving this, so try to concentrate here. So solution, I am given with f of x is given with 4x square plus 12x plus 15. So now here I am having, let us take it as y, which is equal to 4x square plus 12x plus 5. Now to prove any function to be invertible, first we have to show this is 1 1. So let us prove the 1 1ness of this one. Let us take, I will take two elements first, x1 and x2 belongs to the domain of f, and I will have, say, here don't write implies, say f of x1 equals to f of x2, and put the values 4x1 square plus 12 of x1 plus 5 equals to 4x2 square plus 12 of x2 plus 5. So I'll have here converted into a complete square. 2x1 whole square plus twice into 2x1, obviously I have to write because to complete the square, and this is 12 and I have already made 4 here, so should I write here 3 plus 3 square minus 3 square, because to complete the square I needed this term, and to compensate this term I needed a third term. I have written 3 square, and if I have written it extra then I have to subtract this one. So plus 5 was already there, the same thing should be here, twice of x2 whole square plus 12x2 plus 5. In fact 12x2 should be written like this, 2 into 2x2 into, this is 3 plus 3 square, then again minus 3 square plus 5. Now let us see, this one can be written as 2x1 plus 3 whole square plus 5 minus 9, it is equal to 2x2 whole square plus 3 whole square, again plus 5 and minus 9. So you can see plus 5 both getting cancelled, minus 9 and minus 9 also getting cancelled, 2x1 plus 3 whole square, it is equal to 2x2 plus 3 whole square, and since I have told they are positive numbers, so I can write 2x1 plus 3 equals to 2x2 plus 3. So we can write 2x1 equals to 2x2, let us cancel 3 on both sides, and I am getting x1 equals to x2. So therefore our function f is nothing but 1 1. Now let us prove whether f is onto or not. Okay, so for having f is onto or not, let me tell, for onto, f is, look at this, nothing but 4x square plus 12x plus 15. So let me write this one again, f of x, it is equal to 4x square plus 12x plus 5. Now you take it as y, and y is nothing but 4x square plus 12x plus 5. Now same thing, you do the completion of square here, 2x whole square plus twice into 2x into 3 plus 3 square minus 3 square plus 5, and I am getting in the next step y is nothing but 2x plus 3 whole square minus 4, and 2x plus 3 whole square, it is nothing but this 4 will go to this side, y plus 4, and I am getting 2x plus 3, it is nothing but under root of y plus 4, then this is 2x is under root y plus 4 minus 3, and x is under root of y plus 4 minus 3 whole divided by 2. Then you write another statement here at last, for all y belongs to S. What is S? Here you see the question once again, where S is the range of f. So first f from n to n it was defined, but there is a separate range defined, that n to s. So you write for all y belongs to the second set, we have x belongs to the first set. So let us see, for all y belongs to the second set, that is S, we have x belongs to the first set, that is n. So since I don't know about S, so any element I can take such that x will be a natural number. For example, if I take 5 there, it will not be a natural number, but if I take something called 12 there, it will be definitely a natural number, and not 12. In fact, it will be something I can take like, suppose I need x to be a natural number. If I take 12 there, 12 plus 4, that is 16. 16 would be 4, 4 minus 3 by 1, not a natural number. So I will not include that element in S, but I can take some elements in S for which this will be a natural number. For example, you take y equals to 21. So if I take 21, this is 5, 21 plus 4, this is 25, square root is 5, 5 minus 3 is 2, 2 by 2 is 1. So such type of elements will belong to S. So for all y belongs to S, we have x belongs to n. So you write at last this statement, and after writing this one, you conclude that this is a true statement. Therefore, f is untrue. And at the second part, it is asked, find the inverse. X, I can write it is f inverse y, since y equals to f of x, so it is nothing but square root of y plus 4 minus 3 whole divided by 2. So this is the inverse of y.